This is lesson 8.4, and today we're going to be factoring quadratic equations with leading coefficients that are not equal to 1. So far we have only done quadratic equations with a leading coefficient of 1. In other words, where a equals 1. Well, today we're going to work with quadratic equations where a is another integer other than 1. This method that I'm going to teach you is not in a textbook that I know of. It doesn't have a formal name, so I'm going to call it the make a mistake method. I know that's a little strange, but I can't come up with any other name for it. So here are the steps that you will follow. Number 1, for the make a mistake method, you will set up 2 parentheses for your binomial factors, just like you do with quadratic equations with leading coefficients of 1. Then you're going to make a mistake. You're going to copy the leading coefficient as the coefficient of your first term in each binomial, which is an obvious mistake. Then you're going to find the P and S, find the product and sum using the guess and test strategy. Then you're going to correct your mistake by factoring out one of the coefficients. Then you're going to check your factors by using FOIL. You need to know that there are polynomials that cannot be factored. These are called prime polynomials. Prime polynomials are polynomials that cannot be written as the product of 2 binomials with integral coefficients, in other words, with coefficients that are integers. Prime polynomial. Okay, let's get started practicing factoring these quadratics. Okay, number 1, write this down. 5x squared minus 13x plus 6. Okay, so here I have a trinomial. The leading coefficient, in other words, a, is equal to 5. It's not equal to 1. So let's identify a, b, and c. A is equal to 5. Sorry about that. A is equal to 5. B is equal to negative 13. And C is equal to positive 6. Okay. All right, so I can't use GCF. I can't use grouping. This is not where my leading coefficient is 1, so I have to use this make a mistake method. Make a mistake method has me make an obvious mistake. 5x and 5x. I know that that's wrong because if I were to FOIL my first term, my leading coefficient would be 25. So I know this is a mistake, I know that it's wrong, but I'm going to do it anyway and I'll correct it later. Okay? So I'll put 5x and 5x and then I'm going to work on my P and S. Okay? So the product of my 2 integers is a times c, that's 30. And the sum of my integers, b, is negative 13. So you can use the guess and test method. I know my integers are negative 10 and negative 3. When I multiply them, I get positive 30, and when I add them, I get negative 13. So I get 5x minus 10 and 5x minus 3. And now I'm not done because I had a mistake. I made a mistake. I need to correct it. So I need to factor out a 5 from one of these 2 binomials. So I can factor out a 5 from there, and I will. So this is x minus 2 times 5x minus 3. So I believe that's my answer. I will use FOIL to check and make sure that all my signs are correct and that those are the 2 binomials. Let's go ahead and multiply. The first terms are 5x squared. outer terms negative 3x, inner terms negative 10x, last terms are positive 6, and when I combine 5x squared minus 13x plus 6, I know that I'm correct. Number 2, 6x squared plus 22x minus 8. Okay, I'll always go through and look for GCF, possibility of grouping, etc. before I go to the make a mistake method. So as I look at these three terms, I do notice there is a GCF. The GCF is 2. So let's factor out a 2. So 2 times 3x squared plus 11x minus 4. Okay, so now I'm going to bring down the 2, that is one of my factors, and then I'm ready to employ my make a mistake method. Well, I know that this is a mistake. I'm doing it on purpose, and I'll remind myself to correct it later. Okay, so I'm going to go ahead and do my product and sum. My product is A times C, it's negative 12, and my sum is B, which is 11. So I need two numbers whose product is negative 12 and whose sum is 11. Okay, so I come up with 12 times negative 1 and 12 plus negative 1. So I'll have 3x plus 12 and 3x minus 1. Let's not forget to correct my mistake. I can divide 3 or factor out a 3 from that first binomial and bring down my factored expression. So I have 2 times x plus 4 times 3x minus 1. Try number 3 on your own. 4x squared plus 38x plus 70. Don't forget to look for a GCF first, and then you will use the make a mistake strategy. Hit pause, work this problem out, and then check your answer. Okay, the factored form for this trinomial is 2 times x plus 7 times 2x plus 5. Okay, number 4 we'll do together. Number 4, 10y squared minus 35y plus 30. So don't forget to scan the terms and look for a GCF if you have one. Factor it out. So I'll factor out a 5. I have 2y squared minus 7y plus 6. Now I'll employ that make a mistake method. Remember, I know this is a mistake. I'm doing it on purpose. I will correct it in a moment. All right, so I have a product and sum. Okay, my product is A times C, which is 12, and my sum is B, which is negative 7. So I'm looking at two negative numbers, and I know what they are. My two negative numbers are negative 4, negative 3. Negative 4 plus negative 3. So I have minus 4, minus 3. Factor out my 2 from there to correct my mistake. And here's your factored form. I have 5 times y minus 2 times 2y minus 3. Number 5. 4x squared minus 3x plus 5. Okay, so here I'm going to look for a GCF. There isn't any. I'm going to try, it's no grouping. I can't group because it's only 3 terms. My leading coefficient is not a 1, so I've got to try my make a mistake method, okay? So let's go ahead and make a mistake. My mistake is I'm going to say that my first term in each binomial is 4x. I know that that's wrong, but I will correct it afterwards. And I'm going to look for a product and sum. My product is 20, and my sum is -3. So I will go ahead and look for two integers that multiply together to have 20, and their sum is -3. Okay, so let's go through that guess and test process. Okay, I know that my both my integers must be negative. So -20 times -1, that doesn't work. -10 times -2, that doesn't work. -5 times -4 doesn't work. And then -4 and 5, -2 and 10, -1. I don't have any numbers that can fit this criteria. So if you get to that point and you realize you cannot factor this trinomial using integers, then you can state that it is prime. It's not factorable. Okay, number 6. We're going to solve the equation. We're going to solve this equation. Okay, so let's start with this one. 2x squared plus 9x minus 18 is equal to 0. The first thing you have to realize is that your equation needs to equal 0, and if it doesn't, you force it to equal 0. And then we're going to look for a GCF. There isn't any. We're going to see if there's grouping. We can't group because there's only 3 terms. The leading coefficient is not a 1, so we need to revert to the make a mistake method. So let's go ahead and do that. We're going to make a mistake here. Again, we know that's a mistake. We're consciously committing a mistake, and we'll fix it later. And now let's find our product and sum. Our product is -36, and our sum is 9. So I need two numbers that when you multiply together, you get a -36, and when you add them together, you get a +9. As you go through your guess and test, you'll realize that your integers are 12 times -3, 12 plus -3. So we have +12, -3. Let's correct our mistake. We're left with x plus 6 times 2x minus 3 is equal to 0. And then we will solve for both roots. So we have x plus 6 equals 0, 2x minus 3 equals 0. So for x plus 6 minus 0, subtract 6 from both sides. X is equal to -6. On this other one, let's add 3 on both sides. Let's divide by 2 on both sides. So the two roots are -6 and 3/2. Okay, number 7, last one. We'll do this one together as well. I have -3x squared plus 5x is equal to -2. So we'll start by forcing this equation to equal 0 by adding 2 to both sides. So -3x squared plus 5x plus 2 is equal to 0. If you recall, many chapters ago, we learned standard form of a quadratic equation. A cannot be negative. So we will divide each and every term by -1 in order for a to be a positive integer. So we have 3x squared minus 5x minus 2 is equal to 0. Now we look for a GCF, we look for grouping, we realize we need to make a mistake here. So let's set it up. Let's go ahead and make our mistake, consciously making a mistake, knowing that we'll correct it in a moment. And let's find our product and sum. Our product is -6, our sum is -5, so I need two integers that when you multiply them, your answer is -6, and when you add them, you get -5. Okay, the two integers are -6 and +1, -6 plus 1. So we have -6 plus 1, and let's factor out our 3, correcting the mistake we initially made. We have x minus 2 times 3x plus 1 is equal to 0, and let's solve both. X plus 2 is equal to 0. We'll subtract 2 on either side. X is equal to -2. And here we have 3x plus 1 equals 0. We'll subtract 1 on both sides. 3x is equal to -1. Divide both sides by 3. X is equal to -1/3. So the two roots that I have are -2 and -1/3. Here are a few problems that you can work on your own. This is just factor if you can, and if you cannot, write the word prime. So we'll start with number 5 and number 13. And on this next page you will be solving. So on this next page I want you to do number 7 and number 12. Have a great night. God bless you. We will discuss this at length tomorrow. We need to practice this skill quite a bit. So come in ready to apply what you've learned tonight. God bless you. Good night.